Okay, welcome to your third video. Today I feel like is probably going to be the most review that we've had so far, meaning I'm going to assume that you really are following along because I know for certain we covered this in honors. You were tested over it. And so I'm going to kind of fly through it. Now, if you have never seen some of what I'm doing before, then you're going to want to, maybe look back at the slides in Unit 1 for this section, which is 1.3, or reach out to me. A pure substance is an element or a compound, and we're going to talk later about how you can mix those things together and make mixtures. We do know that they follow laws of definite proportion, which basically says that compounds with the same elements in the same proportion are the same compound. Don't get caught up in that terminology. It's kind of self-explanatory. But what we know by that is that we can then find the percent composition. That is the big thing that we're going to be doing is percent composition from the formula. Like we can figure out like what percent of that compound is like maybe hydrogen or what percent of it is oxygen. For example, looking at the masses here for water. So because we know that water is H2O, there's 2 hydrogens, 1 oxygen. If we think about how the total mass of the entire thing is like 18.02 grams or 18 grams, which would be like, 1.01 for each hydrogen, 16 for each oxygen. Those are just masses I'm getting from the periodic table. You then could say, okay, well, like, if I take the 16 grams of the oxygen and do 16 divided by 18, then I would see that the total mass of this compound, 89% of that mass is due to the oxygen, and then 11% of that mass is due to the hydrogen. So kind of go back and look at that slower if you need to, but it shouldn't surprise you that because oxygen has such a bigger mass, even though there's only one of them, that more of that entire mass of the compound is due to the oxygen being there. Now, we are going to be reviewing something we did last year called empirical formula. So we did something last year where we would say, okay, if given the percent composition, can you give me the empirical formula? Or sometimes we would say, okay, can we like think about what the molecular formula would be? So empirical formula is the simplest whole number ratio or simplest ratio of the elements with one another. In other words, if you look at glucose, which is C6H12O6, that's the molecular formula of glucose. It's the true formula of the substance. But if you divide all of those by a common factor or simplify them to their simplest ratio, you would get CH2O, because this would become 1, this would become 2, and this would become 1. Okay, so you're like changing the subscripts to their simplest ratio, and that is called the empirical formula. The molecular formula, again, like I just said, is the actual formula for the compound or the substance. So if you want to know the empirical formula of a substance, you're going to be given percents, the percent composition. And what you do is you always assume that those percents can be treated as grams. And what you're really doing when you say that is assuming you have 100 grams of the substance. Like if you have a compound that's 70% sulfur and you have 100 grams, then you could say, oh, I have 70 grams of sulfur. Okay, you're just converting your percents to grams. And so you take those grams and you do molar mass, you convert them to moles, and then you divide by the smallest number of moles, and that becomes your subscripts. Remember that? Okay, this should be heavy on review. So I'm taking the percents and turning them into grams. Remember, I'm keeping the elements. So there I did. Turn those percents into grams. Then you got to go to moles. You've got to flip them to moles. So I'm doing molar mass. 55.85 grams of iron are in 1 mole periodic table. And 16 grams of oxygen are in 1 mole of oxygen periodic table. Whoops. Then grams, 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 grams. Now I'm into moles. So I get 1.252 moles and 1.879 moles. Remember, keep as many decimal points as you can. Empirical formula, you want lots of decimal places. Then you divide by the smallest number of moles, Remember that from last year? You had an index card you made about that. So this becomes 1, and that becomes 1.5. Now, remember, this is how you're getting the subscripts. These numbers at the end of that divided by the smallest number of moles, that's your subscripts of your empirical formula. A subscript cannot be a 0.5, and it can't be a decimal. It's got to be a whole number. And remember, the rule I told you was that it has to fall within a dime or within a tenth of a whole number for you to round. You can't round 1.5. It would have to be 1.9 or 2.1 or 0.9 or 1.1 or 3.1 or 2.9. It's got to be within a 0.9 or a 0.1 value to round. So what do? You have to multiply both of them by some number, the lowest number you can, that would give you a whole number for that value. So I'm going to multiply them both by 2 because that would make that bottom one be equal to 3. 1.5 times 2. So the formula, the empirical formula is Fe. Take that 2, make sure it goes with the Fe, 2. And then O, well, there's the 3. So there's my empirical formula for this compound. Now, what if you are asked to get the molecular formula? Well, you do the same thing. You get the empirical formula, but then you get the mass of the empirical formula, and then you do a division of the molar mass that's given to you, or the molecular mass that's given to you, divided by the empirical formula mass. Always remember the MM is on top, and then EF. Okay. And then that tells you the number by which you would go in and multiply all of the subscripts of the empirical formula by. Okay, let's just do it. It's definitely easier said than or taught doing it. Okay, how do you get empirical formula? Percents into grams. 72.3 grams of Fe. 27.7 grams of O. Got to flip it to moles. So you can divide by the smallest number of moles. So molar mass, 55.85 grams in 1 mole, 16 grams of oxygen in 1 mole. Going to convert to moles, 1.295, 1.731, divide by the smallest number of moles. That's how you get empirical formula. That's going to be a 1, and that's going to be a 1.33. That's not going to work. I can't round. So I'm going to have to say, let me multiply them all by 3. That'll turn that into a 4, like 3.9, and that'll turn that into a 3. So that gives me the empirical formula. So my empirical formula is Fe3O4. Well, to get molecular formula, I've got to get the mass of that. Okay, so 3 times 55.85 plus 4 times 16. That is going to add up to be 231.55 grams for the empirical formula. Well, the molecular formula mass is 694.7. Divide that by the empirical formula mass, and I'm going to get an answer of 3. So that means I have to go back up here, and it tells you that you multiply all of the subscripts in the empirical formula by that value of 3, or the ratio that you came up with that compares the molecular mass to the empirical formula. So I'm going to say Fe9O12. Multiply this times 3 and that times 3, the 3 and the 4 right here. Okay. And that then is going to answer the question of what the actual compound was, its actual molecular formula. All right, a certain sugar would have these percents. What's the empirical formula? Okay, here we go. Turn the percents into grams. Do moles, 12.01 in 1 mole for carbon. You want to keep the elements somewhere or you'll get lost. So I know I'm writing quick. 1.01 grams in 1 mole of hydrogen. and 16 grams in 1 mole of oxygen. So have the CHO somewhere. Probably should have written it over here by the grams, but. And that comes out to be 3.33 moles and 6.63 moles and 3.33 moles. Well, divide by the smallest number. Divide by 3.33, divide by 3.33, divide by 3.33. So the empirical formula is CH2O, because this is a 1, this is a 2, and this is a 1. But they're saying, hey, now you got to think about MMEF to get the actual molecular formula. Okay, so now you got to add up 12.01 times 1 for that empirical formula of the carbon, 1.01 times 2 for the hydrogen, and 16 times 1 for the oxygen. That turns out to be 30.03 grams that comes from the empirical formula. So I'm going to do molar mass, or the molecular formula weight, 180 divided by 30.03, and that comes out to be 5.99 or 6. So that means I have to take this empirical formula and multiply all of those subscripts by 6, C6H12O6, which is glucose. Okay, I'm not going to do this one with you. I'm going to give you the answers and ask you to do it yourself. The answer is C4H6, whoops, well, that's not writing good, H6P. And the answer down here is C8H12P2. So I want you to do 1.3D by yourself, show your work, check your answers, and then you're going to do these 1.3 additional practice questions, check your answers, and take notes. I think, if I remember correctly, this is a little bit too long. Yep. Okay, I'm going to stop right here. I'll come back and do this second section of 1.3. It kind of feeds into 1.4 anyway, right here. So I'm going to stop right here, and I'll do another video for that section.